As said before, organometallic compounds, such as organomagnesium and organolithium compounds, undergo a significant number of side reactions. The main reason behind this is that the R- formal anion is very basic, which means that even the weakest acid will protonate it and thus convert it back to an alkane. So RMGX will react very quickly and violently with water to give us an almost irreversible reaction, an alkane, so conjugate acid of this base, and magnesium hydroxyhalide. Okay. Now this is an alkane, and this is sort of a dead end for us because it's an alkane, so the reactivity of this compound is gone. It's no longer nucleophilic or electrophilic at this position, it's just an alkane. Now this reaction seems pretty useless, and in most cases it is a nuisance really that leads to the requirements that these reactions perform under strictly anhydrous conditions, which eliminates all water, alcohols, and all other compounds that could protonate Grignard reagents. But in some cases it could actually be useful. For example, if we have this lithium and then we treat it not just with just normal water, but instead with heavy deuterated water, then we will not put a proton on here, but we will instead put deuterium. Okay? And this is an isotope labeled compound. And also it's isotope labeled in a single well-specified position. And this is quite useful because isotope labeled compounds are used a lot to study reaction mechanisms. They're used in medicine to sort of see certain metabolic pathways and things like that. And so this does have its benefits. Sometimes also the point is really not to protonate the Grignard reagent, but instead to deprotonate something else. For example, if we have this isopropylamine, it's sterically hindered amine, and we can use butyllithium, which is a very readily available compound, to deprotonate this. We put the lithium here, and then of course we will get butane as a side product, but that doesn't matter because this is lithium diisopropylamide, which is useful as a base in E2 or E1 reactions. And lithium diisopropylamide is a much better base than butyllithium itself is for these purposes because it's sterically hindered and still strong. Okay. However, in terms of using Grignard reagents as nucleophiles, we are now subject to a set of limitations that we cannot use Grignard or organolithium reagents in combination with molecules which have OH, NH, or carbonyl groups. And the reason for that is we'll get simply conflicting functionality. So if we try to produce a Grignard reagent from this cyclohexyl bromide, this will not work because as soon as it's produced, Grignard reagent will react with the OH group on its own molecule and get destroyed. Right? The same thing could be applied if the compound had a carbon. So this I think is the most dramatic and the first example that we've seen so far of conflicting functionalities. And that means that we need to have functional groups, we need to think about functional groups on our reaction partners and need to think about the side reactions it can cause and sort of plan our synthesis in a way that avoids those side reactions.